Hello friends, welcome to the class on control engineering. So today in this class we are going to solve another problem on root locus. So the problem has been given like this. It is having a open loop transfer function. So g of s into h of s is equal to k s plus 2 into s plus 1 divided by s into s minus 1. So we have to sketch the root locus for this given problem. So let us start by step method. Let me start with the solution. So step number 1, to find out the number of poles, number of zeros. So number of poles, that is denominator terms. So how many are there? There are 2 poles are there. Number of zeros. So in the numerator term there are 2 zeros are there. Okay. So roots, that is, therefore number of branches is equal to how much? 2. Okay. So next, starting point of the branches. What are the starting points of the branch? Always the branches are going to start from poles. So the roots of the poles are 0 and plus 1. So these are the starting points of the poles. So starting point of the branches. So it is going to ending points. So what are the roots of the s? That is the zeros. So it is starting from poles and it is going to end to the zeros. The roots of the zeros are minus 1 and minus 2. Okay, so this is the step number 1. Next, step number 2. What is step number 2? To find out the we are going to draw the pole 0 plot and we are going to predict for the root locus between the roots. Okay, so for that I am going to draw an S-plane like this. So this is 0 plus 1, this one is 1, minus 1 and minus 2. So we have poles. Which are the poles? 0 and plus 1. These are poles. Zeros. What are roots of zeros? Minus 1 and minus 2. So what I am going to do? I am going to consider 0 and 1. I am going to draw the imaginary axis between 0 and 1. So how many roots are lying to the right side of this imaginary axis? 1. That is the odd number. Therefore root locus is possible between 0 and 1. Next, in the same way I am going to consider between minus 1 and 0. So if I am going to draw the imaginary axis, how many roots to the right side? 0 and 1. That is 2 roots are there. It's an even number. Therefore no root locus possible. Now consider minus 2 and minus 1. Draw the imaginary axis. How many roots to the right side? Yes, you are right. Minus 1, 0 and 1. There are 3 roots are there. That is an odd number. Root locus is possible. So root locus is possible between 0 and 1 and minus 2 and minus 1. So this is what the prediction of root locus between the roots of the S. Next one, step number 3, to find centroid. Okay, to find the centroid. And the step number 4 is to find angle of asymptotes. To find angle of asymptote, right? So that is equal to what? P minus Z. What is P? 2. What is Z? 2. So therefore number of asymptotes is equal to 0. This is to find out the number of asymptote, that is P minus Z is equal to 2. If there is no asymptote, there is no need to find out the centroid. So that's why in this problem there is no required to find out the step number 3, that is the centroid, and as well as the angle of asymptote. This you have to show it clearly. Okay, so next one, step number 5, to find out breakaway and breaking point. Okay, to find breakaway and break in points. How to find out? For that we need to consider a characteristic equation. 1 plus g of s into h of s is equal to 0. So what is 1 g of s into h of s, that is k s plus 2 s plus 1 into s minus 1, that is equal to 0. So I need to get a equation for k. So after simplification, so k will be equal to minus of s square minus s divided by s plus 2 into s plus 1. Okay, so this is the value of k. Now what we have to do, we need to differentiate k with respect to s. Okay, so which rule you are going to apply? I am going to apply the quotient rule. What is the quotient rule? D by dx of u by v is equal to v du by dx minus u dv by dx divided by v square. So this is the quotient rule I am going to apply to this. K is equal to this equation. So this I am going to call it as equation number 1. Okay, now so I am going to apply the differentiation, quotient rule, and this can be done as d by dk by ds is equal to, I am taking minus as a common, so it will be outside. So what will be the u? That is s square minus s. What will be the v? S plus 2 into s plus 1. So this can be written as v. I am going to keep it like that, s plus 2 s plus 1 d by ds of s square minus s, right? S square minus s minus formula. What is u? That is s square minus s. So here d by ds of this term. So if I simplify it, so it can be written as s square plus 3s plus 2 divided by whole bracket. So this will be what? What is a v square? What is v? V, this is a v square. So therefore this can be written as s plus 2 whole square s plus 1 square. That means the whole square, right? So this is how we are going to apply the quotient rule. Okay, so after differentiation, we have to differentiate it. So that is after differentiating, and I am going to simplify this, and I am going to write it as 4s square plus 4s minus 2 is equal to 0. So this is after simplification. After applying this, I am going to simplify it and I am going to get this equation. All of you please verify this one. Okay, so with the help of calcium I am going to solve this. So I am going to get s is equal to 0.366 and s is equal to minus 1.366. So we got two values. Okay, now what? Step number 6, right? What is step number 6? So we have to find out, so we have to verify this, right? So we need to verify this is whether it is a valid breakaway or break-in point. How to verify? I am going to substitute these values in the equation number 1. Okay, substituting values of s in equation number 1. Okay, so what is k when s is equal to 0.366? Okay, so you're going to substitute the value of s in this equation and find out the value of k. So we got k is equal to 0.0718. Next, this is a positive. Next, what is k when s is equal to minus 1.366? So that will be 13.928. This is also positive. So though both are valid. Okay, so now which, as I told, there are two points are there, breakaway point and break-in point. In this case, which is breakaway and which is break-in? See, 0.0718, it is between 0 and 1, right? Sorry, 0.36 is between 0 and 1. So these are two poles, so will be breakaway point. So always the breakaway points will be between two poles. Next value is, that is minus 1.36, is that is between minus 1 and minus 2. So these are two poles, so therefore this will be a break in point. So breakaway point will be always between the two poles, break in points will be always between the two zeros. Okay, I hope you understood. So next one is what? So to find out, that is step number 6, to find out the intersection of root locus with the imaginary axis, right? So that is what we require. So for that we need to have a characteristic equation, right? So we need to have a characteristic equation. So that is okay. So next one is to find out the intersection of root locus with the imaginary axis. For that we need a characteristic equation. What is a characteristic equation? 1 plus g of s into h of s is equal to 0. What is g of s into h of s? K s plus 1 s plus 2 divided by s into s minus 1. So that is equal to 0. So if I simplify this, I got s square minus s plus k into s square plus 2s plus s plus 2 is equal to 0. Now what I am going to do, I am going to take the k inside, s square minus s plus k s square plus what 3sk plus 2k is equal to 0. So I need to write the characteristic equation in the decreasing order, right? That is s square. So if I simplify this s square and s square, I am going to take the common as s square. So this is a pairing with similar terms. Okay, so this can be done as 1 plus k s square. Okay, in the same way I am going to consider the coefficients of s. That is s. So here also s is there. So if I combine it, so this can be done as 3k minus 1 into s. Okay, so next is we left with 2k is equal to 0. So what we have to do next, I am going to write the RH method. I am going to apply the RH method. So this can be written as s square is the highest order, s square s to the power of 1 and s to the power of 0. I am going to construct the array as the RH method. So this can be written as 1 plus k, that is the coefficient of s square. So next will be coefficient, I am going to next term, that is the 2k. So next s to the power of 1, that is the, what is the coefficient of s to the power of 1? It is 3k minus 1. So next is 0. So next I need to write to a continue next array, that is s to the power of 0. So this will be 3k minus 1 into this and minus into this divided by this value. I am going to get 2k. I am going to apply the RH method. So this already been done. So we left with what? S to the power of 0 is equal to 2k. Okay, after writing the RH method, now the purpose is to find out the intersection of root locus with the imaginary axis. For that we need what? Auxiliary equation. So therefore I am going to consider to find out the value of k. So for this row, so this all the values must be positive. So therefore I am going to consider this value. I am going to check 3k minus 1 must be greater than 0. Okay, so this value must be positive, this value must be positive, and this value must be positive. See, for these two values, See, for these two values, k must be greater than 0, right? So therefore, so then these two values will be positive. So now I am going to consider this value. So up to what value the k must be. Okay, so if I equate it to 0, so this can be written as 3k minus 1, minus 1 is equal to 0. Therefore, what is the value of k? K must be equal to 1 by 3. See, when I substitute k is equal to 1 by 3, so what happens to this value? So this will be equal to 0. Okay, so this can be considered as what? K margin. Okay, this is a k margin. K margin is equal to 1 by 3. Now to find out the intersection of root locus with the imaginary axis, consider auxiliary equation. So which one is auxiliary equation? So s to the power of 2 term, that is the s square is the auxiliary equation. With the help of this, I am going to form an equation 1 plus k s square plus 2k is equal to 0. Now I am going to substitute the value of k is equal to 1 by 3. Okay, so this can be done as 1 plus 1 by 3 s square plus 2 by 3, that is k is equal to 1 by 3, that is equal to 0. After simplification, s square will be equal to minus 1 by 2. Okay, so what is s? S is equal to plus or minus root of minus of 1 by 2. So therefore s is equal to plus or minus I 0.707. So this is the intersection of root locus with the imaginary axis. Next, what is the step number 7? So to find out the angle of arrival and angle of departure. In this case, we don't have any angle of arrival and angle of departure since we don't have any complex poles. So not required. So step number 7 not applicable. Why? As I told. Now, what is step number 8? So step number 8 is to write down the root locus by using the data. Okay. So for that, I am going to draw the graph. With the help of scale, so I am going to draw a line. Okay. So I need to take the scale. I will be taking marking 2 centimeters. Okay, 2. Okay, like this I am going to mark. Above also I am going to mark. Okay, now. So what is this? This is 0. This one I am going to take it as plus 1, and this one is minus 1, and this one is minus 2. Okay, and this one is minus 3. This is plus I, that is 1i. This is plus 2i. This will be, so downwards, this will be minus I, and this will be minus 2i. Okay, now what is the thing? We have to first mark the number of poles and number of zeros. So what are the poles? That is 0 and 1. What are the zeros are minus 1 and minus 2. So I am going to mark it. So poles I have 0 and plus 1. Okay, these are the 2 poles. What are the zeros we have? that is -1 and -2. So these are the zeros. Okay, next one. So there is no centroid, no asymptote. So next will be, I am going to mark the breakaway and break-in points, so that we have identified, right? So k is equal to 0.366. So 0.36 is between 0 and 1. So therefore it will be a breakaway points. Why breakaway? Because it is between poles. So therefore it will be breakaway. What is breakaway? It is equal to 0.366. Next we have is minus 1.36 is minus 1.36 is approximately, so somewhere here. So this is a break in point. Why it is a break in point? Because it is between the two zeros, so therefore it will be a break in point. So what is a break in point? Minus 1.366. so at this value, what is the value of k here? K is equal to 0.0718. At this point, k is equal to how much? 13.928. Okay, so this is the values of k at breakaway and break-in point. So next we have to locate the intersection of root locus with imaginary axis. How much is this? Approximately plus 0.70i and also minus 0.707. Okay, so this is what the intersection of root locus with the imaginary axis. As I told, always the branches are going to start from the poles. So here we have 0 and 1. So these are the two poles. So it will start from 0 and it will come towards breakaway point and also from 1. So when the value of k is increased from 0 to gradually it will be increased. So this the branch is going to proceed like this. When it arrives at breakaway point, one of the branch is going to break from here and the another branch is going to break and it's moved towards the intersection of root locus with the imaginary axis. It intersects at the imaginary axis at plus 0.707 and also minus 0.07. So at this point, what is the value of k? So k is equal to 1 by 3. So that means 0.33 approximately. The value of k will be equal to 0.33 when it intersects at the imaginary axis. Then if I further increase, so the root locus is going to proceed from here and it will come to the break-in point. It will approach to the break-in point. So at the break-in point, what is the value of k? That is 13.928. After this, one of the branch is going to move towards -1 and it is going to end. Another branch is going to move towards -2 and it is going to end at infinity. Okay, so if I further increase and it is going to end at -1 and -2. Okay, so this is what the root locus for this. Now the main thing will comes, that is the writing the comment. That is the last step number 9, to write the comment on stability. See here, see, from when I increase the value of k from 0 to 0.33, right? So this is the value of k. So this portion is towards the right side of the S-plane. That means when the k is greater than 0, when I increase the value of k that is greater than 0 and less than 1 by 3. So the system is unstable. Why? Because it is in the right side of the S plane. Okay, at k is equal to 1 by 3, so it is marginally stable. Okay, so it is marginally stable. So for the values of k that is greater than 1 by 3, if the k value is more than 1 by 3, then the system is stable. Why it is stable? For the all the values of k greater than 1 by 3. Okay, for all the values of k greater than 1 by 3, the system is toward the left side of the S plane. So then the system is called as stable, right? So k must be greater than 1 by 3 to infinity, the system is stable. So this is the main thing. It carries 2 marks. Comment on the stability. I hope you understood. Thank you. Namaste.